Welcome, everyone. I'm Mark, and we're here for Mark Rober's TA support. For any of you folks out there that need a little help getting started with this week's challenge, please click the link at the bottom of the YouTube stream. Come to StreamYard and join us on screen. We'd love to have you. While we're letting people join, Ryan and Grant, please introduce yourselves.
Hi, I'm Ryan. I'm an industrial designer that took Mark Rober's engineering class last time, and I thought it was a really useful class to do. It's something that allows me to design products and get into the workings of them. And I thought this was an awesome class. It's for beginners to people like me, and yeah, it's such a good class to have. So I'm here to help. If you've got questions, please ask, and I'll do my best to answer.
Thanks. Grant?
Hi, my name is Grant. I currently work as, I guess, a good title for myself, I guess, would be creative engineer. I do a lot of work for escape rooms, designing puzzles and interactive elements. I do a lot of stuff with 3D printing and programming microcontrollers and Arduinos to, act as puzzle elements. Do a lot of building and painting, just whatever needs to be done, whatever creative problem needs to be solved. I do my best to try and solve, which is why I took this class a couple sessions ago. Had a great time, loved it, and happy to be back in this environment, seeing people building things and thinking about these things and totally being surprised and delighted by everything that is being created by everybody.
Mm-hmm.
The man's so talented, they don't even have a job name for him.
I know, right? I have to. Yeah, I don't even know.
It's true, though.
Yeah, I know, right? The job is, can you do this? And then I say yes.
And then you learn how and you do it.
And then, yeah, exactly. Even though I don't really know, I just know that I'm capable of figuring it out.
That's
maybe.
That's really what's going to drive jobs going forward. Not what do you know, but what are you able to learn?
Mm-hmm.
Yeah.
So, well, hey, it's great having you guys. Thank you for joining me again. We might be joined by Chris. He's trying to help somebody work through their they're having trouble connecting their Arduino to their thing. And I'm like, dude, office hours. But yeah, I don't know. But
yeah, so I think Chris has actually been having some one-on-one. He posted something on our page. I'm his left-hand man. I'm the second one there. So I saw what he posted, and I think he's got a few things going on with one-on-ones with other students. So
cool.
That's another option. If you're in some of these groups, there might be TAs posting, one-on-one sessions, their own office hours, like Chris. So Chris is doing that with some of the students in my group, and it seems to be helping a lot. So I think right now, he's got somebody that's got a problem with their Arduino Uno not working, and I'm not sure. Like you said, it could be a defect. It could be the USB cable. I wasn't really sure what else that could be, but I thought maybe too.
It can be a lot of things, but most of the time you've got a bad cable.
Yeah.
That is always my first go-to before I even start bothering to troubleshoot. I'll swap a cable.
Yeah.
But I've seen some really, really weird errors for some of the electronic devices I've debugged. But and I hope it's nothing weird, because weird takes a long time to diagnose.
Yeah, there's been some weird.
So I see we've got Francis in the waiting room. Francis, would you like to join? There you are. Let me bring you to our stream. Welcome.
Hey.
Oh my God, what am I doing on the screen?
That's exactly how I feel too.
No, I'm sorry. I'm just here to learn. Sorry. Actually, it's funny because I had an issue too, just trying to get my Arduino. Well, I'm using the Elegoo one to connect as well. I Googled it, and they're saying, they said, oh, you need to upload your, a driver for your USB. And I'm like, okay, I'm looking at the little chip. I'm at Mega. So I started, down this rabbit hole. And so then I just kind of put it up in my my peer group. I said, is anybody else having this problem? And the TA in my class, he said, like, oh, try this site. And I said, okay, I'm going to do that after work. And so before I started, I just kind of unplugged everything, turned off everything, restarted it. I will confess that one of the things I noticed is I don't know if I plugged my cord all the way in the first time around, and now everything's connected. Now it recognized the port, because I wasn't able to get the port recognized at all.
Mhm.
So I'm almost embarrassed that might have been the reason. So now I'm in, but because I couldn't move on to the next round of like the class, the lesson, until I passed this part. This was kind of like the big holdup. So I'm sorry, this is a very long story, but I actually had this very similar problem with connecting my board to my port and getting that message like, oh, my port is grayed out, that kind of issue.
But you got it.
Yes.
Yeah. But you didn't end up having to install any extra drivers, did you? Or
No,
just 'cause
thankfully
I'm curious
not.
if other people have a similar question. I know that on other boards, like I have these, they're the same brand, they're just a different form factor. These nano boards do need a specific driver installed, and on the box it has a text that says, this product uses this chip, but it has this different chip that you need a driver first. Here's the website to download it from. And I've experienced that with these nano boards, but not with the Uno boards. But that wouldn't be totally surprising if that was the case. But it sounds like you didn't have to install anything extra. It might have just been a connection or something.
Yeah, I think I'm embarrassed to say, because so this plug that goes into the square part of this board, it's much longer. So I noticed that it wouldn't fit all the way in, but then I realized second go around it went in further than I did the first time. So that might have been it. But initially, before doing that, I went down the rabbit hole of like, I went all these boards were saying you need to download these drivers. And I got nervous because, when you Google drivers for the Atmega 16U2, I don't know if any of these sites are legit. I don't have that experience at all. It's like, and I almost clicked on one, but then it said like, click here again to install Driver Max. And I was like, ooh. So thankfully, like I said, I reached out to my peer group to see if anybody else had the same problem. So I would have been okay if it said like, you're going to need to install these drivers. Here's exactly the driver website you need. But when you Google it, from fear, I was too nervous to try it. And I'm glad I didn't. So
yeah, I'm glad you didn't too.
Francis, have you tried any of the code yet with the Arduino program, the IDE program?
Well, okay, so that was my big holdup. Obviously, I couldn't go on to the next. So I kind of just started the first sketch where he's like, change out like 1,000 to 3,000. So I did that. So that's as far as I went. So I apologize. I'm not as far as I should be. But I did want to come on here so I can always kind of hear and learn anything that I might be.
No, I'm just asking too, because I was playing with an online system earlier, and I know they have it with the Arduino IDE, the program you download, but they'll give you examples. And there's actually on a lot of these boards, I have the Elegoo board here too, and there's actually an LED on the board. So when you test, there's one called Blink, and have you tried it? You're doing it now.
Yes. Yeah, I did. Yeah.
So that one will actually test to see if your Arduino is working, and then I had to see if mine was connected too. So that was a good way of seeing whether or not it was actually working. You just, you can upload the Blink program to your Arduino. You don't need to wire anything. There's already a light on it, and it will blink on and off at, I think, 1 second a piece. So that's an easy one, a really easy one just to test. For me, somebody who's a pretty beginner at it too, that was a good way for me to check to see if it was going to work. And then I went on to do some other things because they give you lots of examples that you could practice with and try. And you can even take those and build them into your, your projects later.
No, awesome. Yeah, no, once I was able to finally connect, because like I said, it wouldn't even recognize the port. I couldn't get it to do anything at first. So, but once I did, and then I did that thing in the class where he does that, where he changes it from 1 second to 3 seconds, so that's where I'm at right now. That's as far as I got.
That's good though. That's where you need to begin. So I will share with you guys something that you might find interesting, although my share is hidden behind my camera. A friend of mine is a lot smarter than I am, and he created this website called Walkwe. And Walkwe is an Arduino simulator, actually it's an emulator, I think, more than a simulator, because he doesn't really do the analog aspects of it. But you go to Walkwe and he's got it set up for the Arduino and the Pico and a few other things, and you've got a little Arduino and you can add parts to it, and that you can play around with virtually. Anyways, I've got a little servo one set up here for us where you can actually play around with the code digitally, and it'll make things happen in the simulator. Have I lost audio, or are you all very quiet?
No, we can hear you.
Okay.
I know, I love the graphic.
So yeah, if you don't want, there's a whole lot more to it than this. But if you are a little scared to plug in wires and whatnot first, or you're not sure what things should look like, but you want to start playing while you're figuring out the hardware, that sure is one way to do it. Another one is Fritzing, which you guys may have heard of. I don't know. So anyways, I just wanted to share that. We don't have to spend any more time on it, but I thought it's free. People like free. I know I like free.
No, after you mentioned it in the last video, I went and tried it too. And I really like the fact that you can move the wires around. And at first, I think they do go straight across from the board into whatever items you got listed out there, but you can drag them and pin them so that they're away from the board. You can see where the lines go. It's really useful. I really do like that Walkwe program. It's good.
Yeah, and Francis, you might like it too, or any of the other students who are out there who are trying to figure out how to, how to get things to work. But maybe you don't have the Arduino working yet. That's an option.
Can you upload the code straight from Walkwe to your Arduino, or do you have to send that? You can. Okay.
Mm-hmm. I'm pretty sure you can. And then another good one is Fritzing, which oh no, something's wrong. No, I'm not clicking through yeah, I don't think so. Another good one is Fritzing, which works in a little more sophisticated manner, depending on what it is that you're trying to do. So let me share that one with you now. Yeah, I'm on screen. Okay. So Fritzing is also a simulator that you can play around with. You can, they've got online versions. It looks very similar to Walkwe. Walkwe is more machine level stuff if you really want to get into it and do debugging and whatnot. Fritzing is a little more user-friendly, and it's certainly more developed than my friend's site. And then you can figure out what your schematic's going to look like, figure out how you put this stuff together on your breadboard. And you can play with it from there. So that's just something else too for you in case you're interested in that sort of thing.
Yeah, all these visual examples I think are great. To actually do it on screen, actually see the servo move and see things actually happen, I think that helps a lot. For myself that never knew about those programs, I think that would have been awesome, because I had to go and just try myself. And I think these things on the computer, to try them, do them there first and then do it, I think that's super useful.
Yeah, I definitely agree with you. I had a couple students in my group earlier today just talking about how they were afraid to really install these electronic components into their build because they wanted to be able to take them out later to reuse them and keep messing around with them and try all of the different example projects that are included with their kit and whatnot. And that's just another way to, you should still be able to, use your actual Arduino and play around with that. But that's also another way to do a similar thing, continue to mess around with it and try different things.
No, I agree with that, Grant. Like, I even kept my, I didn't go as far as soldering things with my last build in the last program. I left everything on the breadboard. I just had the breadboard glued to something, and then I wired everything in from there, because I figured the same thing. I figured if I wanted to reuse some of those parts, I could take them all out, use them again. And I haven't. It's still on the other board. But I bought both. I bought their Arduino and the Elegoo pack. I have both of them. So I was able to use different parts for different things. Yeah.
Now, I did want to show something, but then maybe we can walk Francis through a couple experiments together. right? We've got some
Sure.
expert coders here sitting to my side. But
I don't know
before
about
we
that,
did,
but
Ryan and I engaged in glorious battle last time we were together about what was better, the Arduino or the Elegoo kit. Now, I have, and I'm spinning up right now, my microscope. We're going to look at both under the microscope, and we're going to look to see if there are any differences that we can see between them. Oh, actually, you know something? Let's start with something backed off just a little bit. So on the right, we've got an official Arduino Uno. On the left, we've got the Elegoo. You can tell they're different because they have different logos.
Pretty straightforward.
But if you look, it's the exact same components in the exact same positions. The ATmega 328U, the ATmega 328U, the SAMD11 microcontrollers, ESD protection, the same USB. I mean, actually, that's a little different. What they use there, a 505 versus a 500. Okay, a little different. But other than that, from where they ran the traces even is identical. They didn't even bother routing this thing correctly when they stole it. So Elegoo, by all means, used Arduino's design, but Arduino made it open source. They said, it's okay if you do this. But other than that, these things are virtually identical. And I can put it down on the microscope, but these, I mean, even down to where the traces are run, they copied. Which is a shame because Arduino really did a lousy job laying out the Uno from a signal integrity standpoint. But anyhow, they'd be the same, yo.
I think my whole argument in our last battle was that
you wanted a book.
Like the booklet. Now, if I were going to say something good about the Elegoo pack, is it also comes with a great box. if you get the Elegoo pack, I think it comes with more parts, and it actually has a clippable pack. Like it keeps everything nice and compact. Right here, actually. Mine is not as organized, but this thing is also very useful to keep all your pieces together as you go. Whereas Arduino just has a very well designed packaging, but you can't really keep everything together. So there is benefits to one or the other, but again, you can get that booklet online anyway. So even though it's looks good and looks great, it's still accessible for free online. So one way or the other.
Yeah. So anyways, I happened to find both of those earlier, so I figured I'd put them side by side. They're the same. They are the same.
I have one of my employers who hires me to do builds for escape rooms. I've tried having this same discussion because I'll ask him to buy parts for me, and I'll often link the cheaper Elegoo boards because they function the exact same, just to try to save him money. But he always buys the Arduino ones because he's convinced that they're different and they are better. And despite me trying to explain that they are practically identical, I have yet to convince him. So I might send him this video afterward.
Yeah. The Spark. Now hold on. I'm not saying they're better. I'm saying they're equally bad.
Yeah,
like,
that's fair.
I could go off on an electrical engineering standpoint on this aspect. Yeah. Spark Fun Red Board's a little better. There are better ones out there. They just didn't. Is it Massimo? I forget. He didn't do a great job of laying out this board. Something that I've continually asked people to relay to him my displeasure, but I never get a card or a note back. I don't know. So Francis, you want to play? You want to build something?
Sure. Actually, I actually have a very low-level basic question. So I uploaded that first Blink sketch, the example sketch. How do I turn it off? Or is this blinking? Do I just, it just keeps going until I put a different sketch in? Is that what happens?
Mm-hmm. Yep. As long as it has power, it's going to get stuck in an infinite loop and just keep going over and over and over. But if you don't want it to do that, we can teach you how to make it stop after a certain amount of time.
Okay.
But the basic sketch that you uploaded will go on forever.
Okay. So
but there's ways to make it stop.
Okay. And then until I upload a different sketch, I guess, right? Is that the idea?
Yeah.
Well, two ways. One, the sketch that you uploaded is pretty repetitive. It's just going to keep doing that. But we could modify that sketch so that maybe it blinks 15 times and then stops.
Okay.
Other than that, every time you power on that board, it's going to go through that same sequence over and over and over again until power is removed or you upload a new sketch.
And okay, stupid question, I'm sure. By unpowering it, do I just unplug it here, this cord?
Yeah, it's not a stupid question. Yeah.
Okay. I wasn't sure because I've left everything plugged in ever since I finally got this connected, so I didn't want to lose it. But in general, I would unplug this to take the power out. Okay. Okay.
No, those aren't stupid questions at all. And sometimes with some microcontrollers, when you remove power, the program disappears.
Okay. Yeah, that's what I was wondering. Okay.
Yeah. So no, everything's a little different, and those aren't stupid questions at all. Those are good questions.
Just to clarify though, with Arduinos, the program is saved. If power is removed, at least for, I mean, maybe if you wait a million years, it might not be there anymore. But if you unplug it and then power it up again, you don't need to re-upload the program unless you want to upload a different program or a new one or make changes to it. But it saves the program on it.
I suppose if you were to upload like a blank program, like something that had nothing on it, then it wouldn't blink. It wouldn't have anything on it, right?
Mm-hmm.
Yeah. Okay.
So what would you like to learn how to do, Francis?
Oh my gosh. I don't know, because I'm sorry. I haven't even gone through the lesson 9 yet.
That's fine.
So I'm at that stage of like, I don't know what I don't know kind of thing.
Well, let's start. You've got a blinky light, correct?
Mm-hmm. Correct.
Let's make that light do something different. What would you like to make it do?
Well, I guess I'm getting nervous that it's gonna blow out the little bulb, so maybe turn off after a while.
Okay, we can absolutely do that. How do we want to do this, team?
Examples.
Do we want to? So we'll do an increment countdown timer. I guess I'm asking from a logistics standpoint. Do we want to do this virtually on, say, like Walkwe? Do we want to do this live on an Arduino? And whose computer do we want to use?
Well, I sort of think Walkwe might work best. I was thinking about sharing my screen because I was using the online web editor here, but I don't know if I can show it very well, especially if I build it here. I had one I built that I was going to show you in a bit, but I think Walkwe might work best for this, just to show how the light works, right?
Yeah, if you don't mind doing that, then I can monitor the StreamYard in case we get more people joining us.
Okay.
And I won't lose that screen. And I can offer assistance from the peanut gallery.
I will do the same. I'm also going to follow along just because I've never used Walkwe before. So I'm going to take this as an opportunity to just do this project as well along with everybody.
Yeah, I'm going to be learning with you, I think, because this is something new for me.
So do I go to walkwe.com and
let's all go to walkwe.com.
Okay. I'm here.
And then we'll start with, I wonder if we even have just a simple LED. I guess we have to start with the Arduino Uno. So on the far left-hand side, tell you what, I will get us started and then I will hand off to James.
I can throw mine on if you'd like. I don't know how well mine's going to share, but if you'd like me to put mine.
Let's try it. Okay, I see.
Let me know if it's laggy, because I know sometimes my screen, I don't know if it's my distance or what it is, but sometimes mine's a bit laggy here. So I've already taken the Blink application. I have it in my Arduino Uno program here. So this is the online version where if you were to use like a Chromebook that you can't download the Arduino IDE, it's basically the same thing. So I'm clicking the wrong screen here. So normally you'll just start out with a blank program. Let's do a new sketch for a sec. So usually it'll just show up like this, right? So there's nothing in here, it's void. This is what you always get, even in the Arduino IDE. It's just a void setup, there's nothing in here. But what's cool about this is you can go through your examples, right? And it'll give you some of the basics, some of the other things you can look at, different libraries. If you wanted to look up something in here, you can search them. So for instance, if you were looking for motors or something, you could type that in and find different things, maybe a servo. So these might give you some ideas for things you're looking for. But for now, we'll just go back here. We'll go to, was it basic? I think it's under here, blink without delay. So this is the one you were just doing that blinks. And if I go in here, it gives me all the code already. So what I'm going to do is I'm just going to copy this and take it to copy. I already have it in here. So if I were to play this now, you'll notice right here on the board, it's already blinking. Yeah, it's going out 1 second. 1, 2, 3, 4. So it should go on and off. Can you see it? Is it sharing okay?
Mm-hmm.
It's sharing, but it's not simulating on my screen.
Oh, I see it on mine. At least I believe so.
Okay,
Just the built-in LED, right?
I've watched some of these videos back, and I've noticed that sometimes I do lag. So I'm not sure if that's just me being in Canada or what it is, but a little bit far. Can you see that, Francis?
Yeah.
Okay, so that's working. What you could also do is, I think I just saw this here, you can bring in parts. So there's an LED. Maybe we need a resistor here. I'm not sure. Can I switch the resistor? Is this the one we need? I think this is
so
wrong.
Yuri doesn't have the analog simulation going yet.
Oh.
So it's just digital. Something's on or off. So the resistor value, the resistor is essentially a wire right now.
Okay.
So you don't have to worry about changing the value.
Okay. So for me, I like to go to layout. So this is just going to show me how to use it. So in the Arduino program, you can actually see the graph, right? This is kind of similar to what we're looking at in Walkwe, but it's already done for me. So I can kind of look at that and go, okay, so this is the input 13, 1, 3, and there's ground. So you got to just look at how this resistor is placed, and it matters which way these colors are because one is positive and one is negative. So I'm going to look at that. I'm going to go back to my Walkwe over here and try to set it up. You also have to be careful of the LED because the LED has positive and negative too.
I'm going to stop you for 1 second. Resistors are non-polarized. You can
Oh,
put a
they're not.
resistor in any direction. The LED, you absolutely have to put the right way. But
Okay.
resistors don't matter at all.
Well, see, thank you for correcting me. See, I'm learning along here too. So
No worries.
we'll go. So I could put this into either then, right?
Yeah.
So here, this goes to 13,
Mm-hmm.
and this goes to ground, right?
Mm-hmm.
So now that should be able to play the same way. Yeah.
Yay! It works.
Cool. So this is a cool program. I mean, this is pretty basic in terms of what we're going to do with it. But if you were going to wire up an LED into your breadboard, that's one way to do it. Or if you just even solder these, right?
Mm-hmm.
So I'll try to do another one. If you want to do, it's a little bit more complicated. Would you like me to try and do another one? I've got this here.
Well, let's see if we can't get Francis her input first.
Sure.
Oh, I guess I was going to ask. So when you did that simulation, which does that mean it adjusted the coding on the left side, or no? It's separate.
Oh, right. Yeah. Sorry. What we can do is actually change the time on the delay. So if you wanted this to go longer or slower, we can do that. Sorry, that's what we were going to get to.
Oh, no. I was just saying the way you introduced this resistor and this LED light, when you added that all in, did that update all the coding on the left side?
So this is actually the same code. So I just added the LED. This doesn't have to be here because there's already an LED on your Arduino. It doesn't matter. I'm just showing that you can also do this with an external LED that's not on your board.
Gotcha.
So one way or another, this blink is still going to work, and it's still going to blink on both. So it'll blink on your board, and it will blink with the LED. but it's going to work with both. With a lot of other, programs you're going to find within the Arduino program, you're going to have to put them, if they're motors or servos, you put them out here, and then you're going to have to link them up. It has nothing to do with what's going on the board. Okay. This Blink program will, for sure, though. It's pretty much the most basic one you can do. So you guys might have to give me a bit of a hand here, but these are intervals here. So when you go through them, it'll show you.
So that is in milliseconds. So 1,000 milliseconds is 1 second.
Right. So if we were to bump this up, that will loop on and off, 5 seconds on, 5 seconds off, right?
Yeah. Hey, if you don't mind, delete all that comment stuff just so there's less noise in the. Let's just have code.
Yeah.
You can leave those comments. Like that comment's fine, but the other stuff, like who all made this.
Yeah, perfect. So we're gonna try this instead. We'll save that.
So now we're looking at a 5-second cycle time.
Right. So it's a lot slower. It'll stay on for 5 and it'll go off for 5. So really all I did was go in here and change where it says milliseconds. You change that interval. And that's the one thing I always get confused about is the 5,000 interval. But if you think about it in milliseconds, these are the seconds here. So let's do, if we were to do 500, this would be a lot faster. So now it's blinking half a second. Does that answer your question for the speed of the blink?
Yeah, for me, yeah. Though I will say, so I pulled up the sketch from my app, my Arduino app, and it doesn't have nearly as much code.
No, that is I was looking at that too. That is a hard way to get an easy blink out of it, but they're trying to.
I was going to say the same thing.
The people who wrote that were trying to demonstrate some timer capabilities of the ATmega 328. But you're right, Francis. That is a lot of code for a little blink.
Okay. I no judgment from me. I just wondered if my code, the code that I got in my app, is compressed or something.
There's often many ways to get to the same solution, and it depends on your coding experience and the capabilities of the microcontroller, which way you go. Neither one's not better than the other. They're just two different ways to do it.
This was just the example that I had grabbed from the Arduino example booklet over here. So they might have just had more code written in there to exactly show off some of the capabilities. Yeah. But I don't know.
I believe that example is showing you how to blink an LED without using the delay function. Because for some applications, the delay, and every time it's used, when you use the delay command, it stops the microcontroller from doing anything at all for the entire time that the delay is happening. So if you need something to be blinking while something else is happening, you would do something like this that creates a timer and uses that as opposed to just simply delaying.
Absolutely. That's exactly it. Okay, we've got a couple of questions, and then we still have to get back to Francis's thing. How do I turn it off? Because I don't want to burn it out. So get ready for your for loops, guys. Okay, so let's see what we've got. We've got a novel here. Bash Does Gaming Live says, I'm planning to create 4 separate LED circuits for my art build that will be played in a chase pattern by using GPIO to drive relays on each circuit in a timed pattern. Okay. Can you guys advise me on how to calculate my optimal resistor selection and optimal voltage plus estimated current that will be present on each of my circuits? Okay, and I am sure it depends on LED component I select and the resistors I utilize, but is there a best practice place to start? Yes, yes, and yes. Would you like to join us on screen, Bash Does Gaming? I'm going to pull out a bit of paper and I will tackle getting prepped for that one. If you guys want to start with the 4 loops for Francis and then Bash Does Gaming Live, join us on screen, why don't you, if you want to? I'll be back in just a minute. Are you okay with the 4 loop before I run away?
Yeah, I did it a different way.
Okay.
I mean, I just wrote I wrote a little bit of code that has it blink a certain amount of times and then stops.
Perfect.
But it doesn't use a for loop, which I guess means the program still runs. It just doesn't blink the LED anymore.
There's a ton of ways to do this. Whatever way you want to do it, man. Okay, I'll be right back.
Okay. So I guess what's the best way of doing this? Should I share my screen?
I think Mark has to let you do it. I'm not sure. Once you click share, I think he's.
I have to click on something. Yeah. So when you're ready.
Okay. And does this share like my whole desktop or just the tab or?
You will be able to choose.
Share screen. Okay. Sharing screen is easiest with 2 monitors.
Yes, it is. And Chris has joined us as well.
Hello,
Hey,
hello.
buddy. Long time no see.
Yeah, hello.
Grant is about to demonstrate how to stop a for loop while I grab part supplies, and then we're going to show everybody in the whole wide world how to use relays.
All right.
I think I figured it out.
All
hey,
right.
There it is. So this
I'll be
is
back in just a second.
the little bit that I wrote here, and I started from just a completely blank setup here, just because I'm practicing starting totally fresh and writing without having stuff pre-made, which is there's nothing wrong with that. I'm just practicing for myself. This is very similar to what Ryan had set up before with the LED. I have this fun resistor in here that is doing nothing but acting as a wire. But if you were actually connecting this directly to your Arduino, you would want to have a resistor there. So I guess just going over the little chunks here of how I've done this, which again, there's multiple ways you can go about achieving this, but I set out to make it blink a certain amount of times and then stop after it has blinked a certain amount of times. Right here, I don't know how much you've gone over the just sort of the different parts of the code and whatnot. The void setup is only run once, and that only happens when power is applied and the Arduino turns on. It does everything that's in the void setup, and then it moves on to the next section, which is the loop, which whatever is between these curly brackets here at the top and bottom, everything in between that is just constantly run over and over and over and over again while power is applied. I have set up a couple things up top here, just that the LED is plugged into pin 12. And then I have this, this value that I'm keeping track of that I am calling the blink count, and I'm starting it at 0. So it starts at 0 when it's turned on. In the setup, I have established that the LED is an output pin because it can either be an input or an output. But since electricity is being sent out to turn the LED on, as opposed to it being some sensor that gets some input in, I have it set as an output. And then in the loop, the very first thing I have it do is check to see if that blink count value is less than a certain amount of times. And that 10 here that I have highlighted, that's how many times I want it to blink. So the very first thing it does is it checks to see, has the light blinked 10 times? And if it hasn't, it goes ahead and it applies power to the LED, waits a second, and then turns off power to the LED, and then waits a second to get that blinking action. And then it increases that value I had up here by 1, and it resets again. Is the value greater than, or is the value less than 10? If it is a yes, it'll stop doing this. But if it is a no or whatever, it'll continue on. And here's a little simulation: 2, 3, 4, 5, 6, 7, 8, 9, and hopefully it stops after 10. It stops. Amazing. It worked. And I could probably think of at least three different ways you can achieve this exact same effect using different functions and stuff. Mark was talking about for loops. That's a different function that it's an isolated section of code that only does the parts of the code within it while something is true. But if somebody else wanted to go over what that could look like, but this was just my little project that I typed up briefly here while we were all going over plugging everything in. You'll also notice that it is a lot less of code than what was
much
previously
simpler
there.
than what I had to post there.
Yeah. Well, and
awesome.
again, a lot of it is these comments here. Those are really helpful. If you put 2 little slashes in, you can write little notes to yourself. And also, the pre-written code has a little bit more user friendliness worked into it. So like if I wanted to make this a little simpler to adjust, I could change this 1000 over here to, like I can make it words that is a value that I put somewhere else. And then if I go up here, I can just write that number once. And if I just adjust this value, it'll then, every time that delay time that I've established appears, it'll swap that number in. As I'm sure you're seeing, there's a lot of flexibility with what you do. It's a very, very diverse canvas to work with. I've noticed that as I've written codes and stuff for different like puzzles and other displays and such, that I'll often do similar things different every time, or I'll often do something one way, then reference back to a previous project that I did, because I'll be like, how did I do that? I have no idea how I did that before. And I'll look back at a previous thing that I've written and be like, oh, that's how I did it. And also I will often, very, very often, get very small things wrong just with my formatting and syntax and stuff like that. I believe this should still work. Let me double check.
Yeah. That can absolutely kill you. If you misspell something ever so slightly, you can spend a day finding it.
You can.
Yeah. Very cool.
Did you get your paper, Mark?
I got paper, and well, it wasn't just paper I went for. I went for paper. I went for relays. I went for supplies, man.
Here, I'm going to go ahead and...
So I was listening to you, though. That's great and much shorter. Again, it's serving 2 different purposes, though, right? As Grant was saying, it locks up your computer when you put the pause or the delay.
Right.
So,
so anytime there's the delay, the microcontroller, the Arduino, isn't doing anything else at the same time. Now, if you're just doing something where an LED is flashing, that's not a problem. But for instance, I was building this puzzle for an escape room that had all of these like hose valves on them that had to be either turned on or off. And as sort of like just an aesthetic design choice, I have a couple lights that are flashing on it to just signify that something's broken, just a bunch of red lights that flash. And the first time I built it, I was like, I've done this before. I'm going to put in a delay that's going to tell the LED when to turn off and when to turn on. But then the problem I ran into was every time the LED flickers, it's not sensing the sensors that I had in all of those hose valves. So the main part of the puzzle that the players were supposed to be playing wasn't working. It was only working every other second, because the Arduino was only allowed to do, it was doing exactly what I told it to do, and it was delaying turning the light on and off. So I had to go and redo, following the example of the code that Ryan was showing earlier, where it achieved an LED blinking, but it wasn't using a delay function at all, even though the end result exactly the same. One of them is way easier to do, but could run into some complications if you're doing some much more elaborate project.
Yeah,
that's my story of learning that the delay is bad in certain circumstances.
All right, Chris. Now that we have you, man, and we're going to bring in somebody else, and then we're going to talk a little bit about powering LEDs the right way, quote unquote. But Chris, you said you were helping some of your students that weren't able to connect. Could you tell us some of the problems you've been seeing and how you solved them? And then I'm going to figure out why my mouse isn't working and bring in Chase.
Oh, I'm not sure if we've solved them yet or not, but we're getting there. Yeah, one of the students is trying to get his Arduino connected to his Mac. And I'm typically working on a PC, so I grabbed my Mac out of the closet and fired it up and kind of went through step by step with him. And I was able to get mine to connect, but for whatever reason, his USB is not showing. So I did your recommendation, Mark, see if we can grab a different cable to see if it's a bad cable. But then kind of going through the forums and stuff, there's a lot of people who are having some issues trying to get the USB to connect with some of the Arduinos. I did make sure it was an actual Arduino board, because sometimes if it's an aftermarket one, they got a weird chipset in there. So at least we've got that part narrowed down. So we're getting there. And then the other student I was working with, she's just working on a complicated project, trying to get lighting figured out, and actually LEDs were a big part of it. So we just kind of went through that process a little bit and kind of got her going in the right direction, I think. So, yeah.
Well, sweet. So, well, thank you for that. And joined now, we've got Chase. How you doing?
Good. How are you guys doing?
Good. So, Chase,
Doing
are you
good.
Batch Does Gaming Live as well?
That's my son. My my 12-year-old hijacked my YouTube account probably about a couple weeks ago for his live streaming account.
No worries, man. So tell us about your problem, and we're going to tell you how to solve it.
All right. Well, so for build number 2, I had an idea to build kind of timely that it is Carl Sagan Day, and I'm a huge physics nerd and astronomy nerd. So I'm going to build kind of a mirrored backing tesseract shape, and I want to build that out kind of like clear tubing maybe, and I want to make LED circuits that kind of chase out inward from the outer cube to the inner cube down the vertices. So my idea was to make these 4 LED circuits that are just kind of linked up, LEDs in line for the outer cube, a second circuit for the next step down, a third circuit, and then a fourth circuit for the inner cube, where the LEDs are kind of just like highlighting the shape. But I'm not sure, because there's different amounts of LEDs in each circuit. Number one, the best wiring method for this, and should I be basically doing everything in series with a resistor after every LED, or is there a better wiring method for each circuit? And then how do I calculate my optimal voltage and resistors for each of those circuits? How do I kind of do that math ahead of time before I fry a bunch of components in the process? I'm sure I'm going to fry some, because I've already done that. I actually fried my bench power supply last night when I was so I'm ordering a new one already. But I kind of want to figure out ahead of time, do a little math on paper to figure out what I'm expecting for voltage. Is this something that I can do with a single power supply, to all 4 circuits? Should I be breaking this up? Do they all need different voltages? I'm just not sure where to start with calculating that.
Okay. And how many LEDs do you think you'll be using?
I think right now I'm planning on, it's 4, 8, 12, 24. So my thought is that I'll have 30 on the first circuit, and then it's actually much smaller. It'll be 4 on the second circuit, 4 on the third circuit, and then probably 8 to 10 on the fourth circuit.
Okay. All right. So that's actually a lot, but we're going to help you get started by all means.
All right.
I'm just trying to figure out. Oh, Mark's big. All right. So I've got a little bit of information for you. The first thing, do you know what a shield is for an Arduino?
No.
So Arduino has these little things on the side that they call headers. And what you can do is you can buy something that goes on top of it that's called a shield. This is just a generic proto shield, but they have all sorts of different ones. Basically, they just plug in, right?
Mm-hmm.
And one of the things that they can plug in is relays.
Okay.
So you can get a relay shield that has 4 relays on it. And the cool thing about a relay is that it protects the Arduino from whatever it is that you're doing. Let me silence that. Sorry about that. So the Arduino is only going to be able to deliver so much current. And if you're running 30 LEDs, it's not going to be able to deliver enough current.
Right.
So you have completely separate circuits that run through the relays. So let me take a minute to talk about a relay, because that's always interesting stuff. A relay is an electromagnet. You said you've got a teenager.
Mm-hmm.
When he was in elementary school, did they do the thing where they wrap the wire around the nail and hook it up to a battery?
To magnetize it?
Yep.
Yeah.
So that is exactly what happens in a relay. There's a piece of metal.
Mm-hmm.
There's a, I'm not even on screen, am I?
You
Sorry.
Are. Oh, no, yeah.
That's the wrong button. That's the right button.
Yeah.
So there's this coil of wire, there's a magnet, and connected to it is a switch. So there's, for lack of a better example, there's a piece of flappy metal that has a spring attached to it, and the spring will make it come back to one side, except when this is energized, in which case it comes over to this side and it makes a connection. That's way too much light. Okay, so a relay, whenever this thing's energized, it's going to take a piece of flappy metal and it's going to connect, and it's just like flipping a switch.
Right.
So this is the part that gets hooked up to the Arduino. So it can have a very, very little bit of electricity that you can use to then control much bigger things with electricity. And we're going to run all the current through the relay so that you don't have to worry about frying your Arduino.
Right.
Kind of cool so far? All right.
Oh, yeah.
All right. So now on to LEDs. LEDs are a bit of a pain in the butt in the wiring world. It's not like your regular lights, right? You flip a switch, the light comes on. LEDs work a little different. You've got to get to a threshold voltage before they'll turn on.
Mm-hmm.
So if you figure out what LED you have, you're going to see a graph that looks a little bit like this. And what it tells you is that up until you get to like 0.7 volts or whatever it is for your LED, and if you give me a part number, I can tell you what these numbers are specifically, but
Right.
It's not even going to turn on. But then when it does turn on, it's going to need 3 milliamps of current. And then as you go up to say like 2 volts, it's going to need 5 milliamps of current. And you've got to limit the amount of current that can go through that LED. Otherwise, you burn them out.
Mm-hmm.
Cool so far?
Yep.
So the basic circuit, let me make sure that I'm on screen. If I draw a symbol that you don't recognize, please let me know.
You're good.
You know,
power source, battery.
Yep.
Or power
Perfect.
Source.
LED,
Mm-hmm. Diode, yeah.
light emitting diode, resistor.
Mm-hmm.
All right. So current, right, the charges, the electrons, they've got to go through all this stuff.
Right.
However much goes through the LED has to go through the resistor. So if you go over and you look at well, I guess I should say one other thing. However much current goes through the LED has to go through the resistor, and however much voltage that you start off with, let's say it's 5 volts, that's how much you have to use. There's no saving it or doing anything else. It's either going to go through the LED and drop over the LED, or it's going to drop over the resistor. So you go and you look at your graph and you say, okay, 5 milliamps at 2 volts of electric potential difference there. That's where the graph says it is. This is what the data sheet characterization says.
Mm-hmm.
So I know that LED is going to be dropping 2 volts, and it's going to take 5 milliamps to do it. So that means if this is using 2 volts, then that resistor is using 3 volts.
Mm-hmm.
And it's also going to be 5 milliamps of current. Okay, so what do I do with those? Well, there's this thing called Ohm's law. The potential difference equals current times resistance, or in our case, we want to know what R is. Well, that's just going to be our delta V over our I, or 3 volts divided by 0.0005 amps, which comes out to, give me a sec, is that 600 ohm? It's too late at night for me to do math.
Mm-hmm.
600 ohm, yeah. So then you would go and find a resistor that is close to not 6,000, I just said 600. You would then go find a resistor that's close to 600 ohm.
Okay.
That's the basic process. Now, on to best practices with your LEDs. All of these LEDs are a little bit different. So if you are connecting these things in parallel, you can't assume that one resistor is going to do the job and then it's going to split the current equally through the rest of them. It doesn't work that way. So each gets its own. Resistor.
Okay.
As you tie it down to ground. And then the next question, what kind of power supply do you need? So each one of these little subcircuits, right? Each one of these things, if you do decide that 5 milliamps is what you want. And by the way, why did I pick that number? That's a decent number for a pretty bright LED.
Mm-hmm.
But you're going to see other curves in there that compare current to brightness.
Mm-hmm.
So you can see where brightness hits to pick your current, see where current hits to pick your voltage, and do the math from there.
Okay. Now,
going back up over here, you would say, okay, so I've got 30 LEDs times 0.5 amps a piece. And then that would tell you, okay, well, I've got 15, is that 150 milliamps to worry about?
Yeah, 150 milliamps.
All right. That's not a lot in the world of power.
Mm-hmm.
So you can use an old power supply from something easy if it's the right voltage. You could use a battery, easy.
Okay. That helps a lot. All right.
Sure. Grant, how would you make this little LED thing?
I would honestly, given my knowledge and skill level about electronics, I would probably buy one of these. I actually have one in front of me. These LED strips that you'll notice it has LEDs on it, but it also has a lot of other components on it. This particular strip just takes 12 volts and all of the hard work is already done for me. So all I would have to worry about is figuring out how I'd want to automate them and animate them. But that totally skips the understanding of all of this stuff. And in fact, I've done a lot of individual LED stuff with Arduinos and like lights and stuff, as I said. And I've definitely just skirted my way through understanding this right here. And I'm sitting here, I've got this whole kit of different sizes and color LEDs that I just bought for a couple things that I'm building. But in the lid, it has the voltages and the currents of all of these different colors. And I've been sitting here doing the math to figure out which resistors I'd need for each. And here, I'll put that back up again. It's super clear. You can read it. No, you can't. But like, for instance, the the regular sized white LED that's about this big. It's 3.2 to 3.4 volts, and it's a 20 milliamp LED there. So I was just sitting here, and if I was using the Arduino to power it, which those operate on 5 volts, I was calculating what resistor I would need for that specific LED, and that's where I was interrupted just now. Not interrupted, just summoned by Mark and asked a question. I had my calculator app on my phone, and I was sitting here like, okay, have I been doing it? Because it's been working for me.
Yeah,
but
there's a whole range that these things can work at.
Right.
There's an entire range that these things will work at. You're varying the brightness depending on how much current, the current and voltage curves.
Right. Okay, great. Well, that helps a lot. I do appreciate it.
Sure. But I like what Grant was saying, man. Home Depot right now has got, these LED strips for like $10.
I've got a roll of them sitting right here next to me on my bed, and I considered it today. I was thinking, I could just do that, and that would probably make things a lot easier. But at the same time, I kind of like trying to figure this out a little bit and see how complicated it might be. But for the actual build, it may make a lot more sense to do that. It'd be really easy to adhese that to whatever shape I'm making and kind of run that around my rim and my form that I'm making for the Tesseract. So,
well, I got the impression you had no trouble following what I was doing.
Yeah.
So do it. Have some fun.
Yeah, I'm a math nerd, so I do love following that. Sometimes
What group? Do you know who your TAs are? What group you're in?
I think you are. I'm not sure. I think you're the only TA I've seen post in the group. So I think you're the TA for that group. Okay,
well, hit me up, man.
Okay.
I know communication back and forth is kind of hard, but I'd be happy to help you, especially if you know what LEDs you have. If you do want to go down this route, I'll help you interpret the curves.
Okay, I appreciate that. I'm going to do some testing, probably with the pre-made LED strips that I have here, and just see what I want to do and if that seems like a better fit. And then if it gets stuck, I'll reach out to you. I appreciate it.
Sure.
Chris, quick question, Mark.
Oh, sure.
I don't know if there's probably no way you'd know this just by looking at it, and I probably have the information in front of me. But typically, are these LED strips, are the LEDs individually addressable, or are they just are?
So if
Chase wanted to like animate it and have it, all of the lights, going in a sequence, would this be?
If there's 3 wires,
there are
serial addressed LEDs.
Okay.
So they use something called a one-wire protocol. If there are more than 3, like it says RGBW and ground, so there's like 4 or 5, then they're not individually addressable. They all do the same thing at the same time. But if it's 3-wire, it's the only thing it can be.
Gotcha. So this one has 3 wires, and then it has what just looks like power. So I'm assuming this strip is just they all.
Wait, hold on. It's got 3 wires plus power?
Yeah.
Those are not individually addressable.
Okay, gotcha. This one, you can control them, but they're all going to be the same color. Gotcha. Okay, good to know.
So
That's what I bought them for. Little fancy backlighting.
Yeah. If I didn't have individually addressable strips like that, I could still go the route of creating potentially 4 separate circuits of those LEDs, and then still controlling those circuits individually with my code, right? Just doing like GPIO-driven relays to trigger the power and time. Okay, awesome. Well, I've got some testing and some playing around to do.
Yeah, absolutely.
All right. Thank you guys for the help. I'm going to get back.
Yeah, thank you.
All right. Thanks so much.
Chris, how would you tackle that problem?
I'm kind of with Grant on this one, actually. If there is a fixed space that, I have constrained proportions that I know I got like 6 inches to go down each side, I would use a pre-made strip. if I didn't need them individually addressable. If I wanted to, control each one or have different effects, like the student I was working with earlier, she's actually playing with some fiber optics. At that point, I think individually addressed or individual LEDs would be the way to go. But if I'm just trying to lighten an interior space, I'm a big fan of pre-made strips. That's what I did with my enclosure for my 3D printer is, I have a light that basically turns on and off when the print is running. So when the print is running, I got the light on, I can see everything that's happening. When it's done, it shuts off, but I don't need anything fancy in there. I just need it to be lit up. And that's where the strips really come in handy. For one of my projects, I only needed a couple lights. I needed, individual colors. I needed a blue, a green, a yellow, and a red. I just used individuals. I think it just depends on the build that you're doing. But like I said, fixed space, if it's a box, I love a strip of lights. It's just fast and easy. And I would rather dedicate my time to other portions of the build versus messing around with a bunch of individual LEDs, especially on a short time frame.
I will tell you something, especially on a short time frame. I've shared this with you guys in the past, right? The build for Mark Voids of Warranty. I have yet to turn this thing on. You want to know why? I installed every single LED backwards, and if I turn it on, they'll all explode.
Yeah.
Every one of them.
Practically a grenade.
I mean, with that level of consistency.
Well, you're 100%.
100% wrong.
You're 100%. Yeah.
So, Francis, you've been sitting there quietly. What do you think about using LEDs in your build? How will you use them?
Well, to be honest, it sounds great. It's a little ahead of myself because I haven't even done so. The first in my group, the first assignment is due tomorrow, and like I said, because of my late start with my issues with connecting my port to my Arduino, I'm only starting to finally follow the lesson. So, like I said, I'm a little behind. So I'll probably have more questions at the next TA hours. But so far I'm really just really at the basic part. So I haven't gotten to really thinking about the brainstorming part, though. Given the time constraints with my first project, I think I know I want to make sure it's scalable for the time commitment, time allotment, pardon me.
That's a good call. So, all right then. Any other thoughts before we call it a night over here?
I've got nothing.
No, nothing new here.
Any ideas on how we can attract students to TA hours?
I am going to beg again for some sort of a sticky post.
Yeah. Yeah, I've just been trying to post regularly because I know that it can easily get drowned out, and also it's not consistent as like an alert because people are engaging with the platform at different times. So I'm sure some of them I see them post a lot right after I have waken up, and I'll respond to all their comments, and I won't hear back from them until the next day. So I realize that everybody has different times that they're sort of engaging with the class, and it's sort of hard to target making a post to reach the most amount of people. But yeah, so far I've just been posting in advance. I have one post that has all of the links for all of the things we've planned out, and then posting day of. I don't think anybody from my group has joined yet, but I'm hopeful it'll happen soon.
All right. We can just lie to him, tell him Mark Rober will be here.
Yeah, Mark's here.
Yeah.
Mark's there. Yeah.
Yeah, Mark will be there.
Mark will be there.
I'll do that for the next one. I'll say Mark will be there.
As a student, I will say that it's only been posted once, the hours. So, and I had to kind of go back into the peer group thing to say, oh my gosh, where's that link to that YouTube part? So that's the only thing.
Yeah, there's no way for us to get it to sticky or for it to show up more often, unfortunately.
Right.
So today I tried posting it just earlier today to see if it would stay top of the feed, but I don't know what to do. So, all right. Well, thank you everyone for your time. Hopefully we'll get some more students in here. Ideally, we'll have so many students that we'll have to do breakout rooms.
No, that'd be good. We'll get
But-
there.
Yeah.
For now, I am really glad that Francis keeps coming back. We must be doing
Yeah, it was nice to see
something
you,
right.
Francis.
Thank you so much for doing this. I really appreciate it.
Hey, the student to teacher ratio is better than you'll get in any college
Anywhere.
class.
I know. I need to get back up to speed in the class so I can be like, I need help with this. So yeah.
All right. So Friday, 6 p.m. Pacific. We're back. So, all right, everyone. This has been Mark Rober's monthly TA office hours with Chris, Grant, Ryan, and Mark, and Francis. Thanks, everyone. Have a great night. Bye.
Good night,
guys.
everybody. Thank you.
Bye. Nice seeing y'all again.
You too.